All right, now the last thing we're going to look at in this module is doing tests about a population proportion, and we're going to do this example right here. And to do this example, we've got a couple of new formulas we're going to work with, which are right here. And to understand these formulas, we need to, and I'm just going to move this over to the left, we need to see some new notation, which right here, I put it onto our little diagram. And so a p with a bar over it, just like we have an x over a bar with it, a p with a bar over it is our sample proportion. And so you can see here, there's our sample proportion right there. And this is a z. We're doing another z score here, another z calculation. What's the z value? And the z value is like the way we've been working with it. The z value is like the distance, how many standard deviations is a point from the mean. And so here we're looking at what is the sample proportion, and then how far is that from p with a subscript of 0, which is the hypothesized population proportion. So there is a population proportion. It is p, just straight p. But a p with a 0 is like our null hypothesis has a 0. This p has a 0 because now this is the hypothesized population proportion. And that could also be what the population proportion is. It can be also just p. And then down here we have sigma with a subscript of a p bar. And sigma with a subscript of a p bar is the standard error that we use. So I asked ChatGPT about these symbols, and this is what ChatGPT had to say. So this is about that exact problem. So we have p bar, which is the sample proportion. So sample proportion right there. And you can read through it right there. And then p with a subscript of 0 is the null hypothesis proportion. And it's the population proportion under the null hypothesis. This is the proportion you're testing against, often referred to as the claimed or hypothesized proportion. And in this case, in the example we're going to do, p naught will be 20% of women are golfers, right? Which is also kind of what's been observed over the years. That could also just be the population proportion is what we're using for this, the null hypothesis proportion. So it's the null hypothesis proportion, right? And then we have the standard error, which is sigma with a subscript of p bar. And standard error is the standard error of the sample proportion, which measures the variability of the sample proportion from the population proportion. And it's calculated as this. So that's the notation. There's a little bit of a summary of it. That's the first thing you need to know to sort of understand this. We've got some new formulas, and then we're going to use these formulas. And the way we're going to use them, I'm going to open up a new window here. So let me just bring this over here and then put it right there. And the way we're going to use them is right here. So based upon this example, we're going to fill out all this information here and then do these two problems here, and we'll get our standard error. And again, standard error is the standard deviation of a sampling distribution. And so here we have our standard error, standard deviation of a sampling distribution. And we plug in all these values, and we plug them in here, and we do the calculations, and we get 0.02. Right? And so I'll walk you through all that. But the first thing we want to do is develop our null hypothesis and our alternative hypothesis. And again, when you're putting together your hypotheses, the number one thing you want to do is think about the null has to be the current state, that there's no change, and it's the status quo. And so currently the current state, the status quo, is that 20% of players, of golfers, are women. 20% are women. And so that current state that's going to be our null state, right? Like nothing changes. We're going to have 20% or less players are women. And so the null hypothesis will be that the proportion is less than or equal to 0.2. And the alternative is change. Things have changed. And so, after, this marketing has been done, they then do a random sample of 400. So n is equal to 400. And out of all those people sampled, 100 of those players were women. So 100 over 400 is 1 over 4, or 0.25, right? And so we put 0.25 as the sample proportion in here. But that's going to be our alternative hypothesis, that the population proportion, p, is greater than 0.2. P is greater than 0.2. So those are our hypotheses. And then we fill all this out We have an alpha or level of significance of 0.05. That's given to us right there. Level of significance is 0.05, which means, by just its counterpart, the confidence level, confidence coefficient is 0.95. So with a sample size of 400 and with a population proportion of 0.2, that will be our, and how did ChatGPT say it here? It's our standard error of the sample proportion is that sigma p, and so the sigma p is the standard error right there, but the null hypothesis proportion, right? So the null hypothesis proportion will be 0.2, and so we fill all this in here, and to fill it in, I'll just make this larger. I think we're done with that one. We'll make this one bigger, and we'll go to the next slide. To fill this in, we have the null hypothesis proportion is 0.2, and then we have 1 minus 0.2 is 0.8, and then we have 400 as our n, and we do the math on that. We get the square root of that, and that works out to 0.02. So that's our standard error of the proportion, standard error of the proportion. Again, just going back and making sure that we have the terminology right. Standard error of the sample proportion, because p bar is the sample proportion, and we have p bar here. So I'm still learning how to say all this stuff too. But we have the standard error of the sample proportion, it's 0.02. And now we're going to calculate our z-score. And so here's our z-score, and our z-score is going to be p bar, and p bar, and so p bar is the same, and we'll call this p bar. Because I don't know how to make p bar show up on my keyboard. But p bar is the sample proportion. And again, just checking our notes, p bar is the sample proportion. So we have our sample proportion minus p subscript 0. And p subscript 0 is the null hypothesis proportion. So I'm going to put this over here too, just so that we have this here. And we'll put that null hypothesis proportion. And we'll do, and we don't need that, and we'll just do that. That's 0.2, and so we have this sample minus the null hypothesis proportion, which is 0.2. And if you think about the way a z-score works, it's like how many standard deviations is a certain point away from the mean. That's how we've learned what a z is. But now we're saying how many standard deviations is our sample proportion away from the null hypothesis proportion. And then we have down here our standard error for the sample proportion, right, for p bar. So when you plug in these numbers, 0.25 minus 0.2 divided by 0.02, you get a z of 2.5, z of 2.5. So when you put all this together, and I'm just going to move this over to the left, and I'm actually going to open that one window again and bring it back over to the right and keep this one on the left. But when you put all this together, you get this drawing right here. And so this drawing right here actually needs to be updated, and I did update it because I did, I'll show you what I needed to improve. So I'm going to pause this video for a minute and get that updated version. Hold on 1 second. Okay, I'm back. So here we had, before I just had 0.9938 here, and 0.9938 is the data from this point to the left, and we really need the data over here. All right, so we got our z-value of 2.5, so I put my z-value down here of 0.25, and this is the critical value approach and the p-value approach. And we also have that we're at the 0.05 alpha level, which is 0.05, and that's our level of significance. So that means that 5% of our data is this way and 95% of our data is that way. And we're doing a one-tailed test here, just like with the one that we were doing where it was 3 pounds of coffee was a one-tailed test. And then also Heathrow Airport, right? Did you get a rating of 7 or more? And so here we're really looking to see if we got 0.2 or more, right? And with the coffee, we were looking to see if we had 3 or less. Right? And so, we were determining which tail we were using based upon those scenarios: coffee, Heathrow Airport, and now women golfers as a percentage of a proportion of all the golfers, male and female. How many of them are women? And so we're doing one tail up here. 5% of our data is to the right, 95% is to the left. So at 0.05% of our data, we could go to our Z table. And our Z table at this is like 0.05 means that 95% is to the left. And so if we look for 95%, we have here 95, 94, and then here's 95.05 and 94.95. So this would be 1.645, right, between those two. And so we get a z-value for this location of 1.645. And then we have 2.5 over here as the z-value that we calculated, 2.5. And we now need to figure out at 2.5, it will tell us like how much of our data is from here to the left. So if we go to the z-value of 2.5, and there's no like 2.51 or anything, it's just 2.5. So it's right here, it's 0.9938. So at this point, 0.9938 of our data is to the left from here over to the left, which means that 1 minus 0.9938 or 0.0062 of our data is from here to the right. And so both of these, whether we're using the p-value approach or the critical value approach with the z-value, right, both of these tell us that our sample data put us well in this range where we can reject the null hypothesis that the proportion of the population is less than or equal to 0.2. And we could say with 95% confidence that the proportion of the population is greater than 20%. It's greater than 20%. That's what each of these tell us. And so that's doing this proportion deal. And I'm going to close this and then open this back up, make it a little bit bigger. And so we could say with 95% confidence, you know, that more than 20% are women of the population proportion. If you want to read through how the book talks about it, like they have these rules right here, and if you apply these to this graph we just did, they can make sense. And then they also have their calculations right here, and also right here, right? And then also right here. And so that's how they're doing their calculations. And then that's the end of this module. It takes some work. And the one other thing I want to share with you is that after I calculated everything, I just took that, you know, so here's that image with, here's the example about, you know, that we're going to do about the women golfers. And then here's that page I created with, you know, the formulas and putting in like, you know, my null hypothesis, my alternative hypothesis, all that stuff. Well, there it is right there. So there's that one, there's that one right there. And then I uploaded this image with 0.9938. And I said, hey, can you check my work? And it checked my work, and you could pause the video and you could read this right here. And then you could pause the video and you could read this right here, right? And then you could pause the video. Oh, well, now we're getting into the next one, which we already read. But this is where I was like, wait a minute, 0.0062, and it caught my error. And my error was that on this, I just put in 0.9938, which gives me the percentage of the proportion, you know, the probability of everything over here to the left, right? And I needed to subtract this from 1 to get everything to the right. And so when I did that, it made sense, right? It made more sense. And so that was kind of cool about ChatGPT, and I also liked its explanation right there. Okay, I know this is a lot. Again, just work examples and have ChatGPT if you're paying for the paid version. The free version creates errors, but the paid version, I've yet to come across an error. But have it create some problems for you and work those problems and then check your answers and do that until you get some sense of understanding of it. Have a great night. Have a great day, whatever time it is, wherever you are. I hope it's a good one. Talk to you later.